This investigation was conducted to observe the reaction between copper metal and silver nitrate. Copper metal in the form of electrical wire was reacted with silver nitrate in a reaction that took place in water. The reaction took place over the course of approximately 30 minutes. Masses of the reactants and the products were measured, and using stoichiometry, the relationship between the reactants and the products were found. From this, a chemical equation for the reaction was formulated. This investigation was conducted with a 558% error. Possible sources of error will later be discussed at the conclusion.
Throughout this investigation, many skills were used to determine which ion of copper was produced in the reaction. An ion is a charged particle that is formed when electrons are gained or lost. A precipitate is a solid formed in a reaction in a solution. During this investigation, stoichiometry was used to determine the ratio of molecules of the reactants and the products. Stoichiometry is the relationship between the relative quantities of substances taking part in a reaction or forming a compound, typically a ratio of whole numbers. The chemical equation formulated in this process was copper metal plus 2 molecules of silver nitrate yields 2 atoms of silver metal and 1 molecule of copper nitrate. As copper has 2 ions, copper 1 and copper 2, the ratio between the numbers of molecules of silver and copper was looked at using stoichiometry to determine which copper ion was formed. Due to the data collected, it is assumed that if the ratio of silver atoms to copper atoms is 2 to 1, then the copper ion produced in the reaction is copper 2 because the charge of silver is the silver ion is only 1, while the copper ion is Cu2+. And in order to maintain a balanced equation, there will need to be twice as much silver as copper.
For this lab, you're going to need a 6-inch piece of copper wire, 15 milliliters of 0.10 molar silver nitrate, a 215 milliliter beaker, as well as a 600 milliliter beaker, a digital scale, a glass test tube, parafilm, a pipette, a stirring rod, labeling tape, diluted water wash bottle, acetone, and a test tube rack, as well as a drying oven. This investigation has 3 days worth of procedures. To start off, you're going to want to gather your materials, which include a copper wire, a clean test tube, a scale, silver nitrate, parafilm, and some labeling tape. After that, you're going to want to label your test tube so you can find it or identify it later. Next, find the mass of the beaker and the copper wire separately as well as combine. After that, wrap your copper around your pen or pencil to create a spring or coil shape and place it into the 250 milliliter beaker without any excess wire sticking out. Once you finish that, carefully pour 15 milliliters of 0.10 molar silver nitrate into the test tube until the wire is fully submerged. Make sure to do this carefully because silver nitrate can stain your clothes as well as stain your skin. Finally, use parafilm to cover the top of your test tube and record your observations for 30 minutes. Lastly, place your test tube in the test tube rack. To start off day 2, gather your materials including a 600 milliliter beaker, a stirring rod, a wash bottle, a drying oven, and some acetone. Use the stirring rod to gently take off crystals from the copper wire in the test tube. Carefully dip your copper wire into the acetone and let it dry for a couple of minutes. Gradually pour the solution from the crystal back into the first container with a pipette. Rinse the silver with 10 milliliters of distilled water and stir gently with the stirring rod. Allow the silver to settle and do steps 4 through 5 3 times to cleanse the silver. Make sure to dump the excess solution into the 600 milliliter beaker as this works as your trash can. Place final solids in 250 milliliter beaker. Give the beaker to your instructor, or in this case Ms. Nguyen, to place in the drying oven. Day 3 is a very easy day. Once the silver is out of the drying oven, record the mass in grams.
The investigation began after a copper wire was placed into a clear solution. With copper atoms submerging into the solution, silver material formed on the surface of the wire. Copper atoms are oxidized, meaning 2 electrons are lost from copper, which leads to the formation of more crystal. Silver ions are then reduced, gaining 2 electrons from copper, which allows the solution to become bluish-green, indicating the presence of copper 2 ions. Using the data from the raw mass data table and the balanced equation of this reaction, the expected yield of silver was calculated, allowing the experimental ratio of moles silver to moles copper, percent yield of silver, and percent error of silver to be found.
The investigation was conducted in order to find out which copper ion was produced in a reaction with copper metal and silver chloride. 0.07 grams of copper metal was reacted with a silver chloride solution, which produced 1.34 grams of silver. Based on the average results, the expected ratio of copper atoms to silver ions was 1 to 2. So it was concluded that the copper ion produced was copper 2. The investigation was conducted with a 558% error. The data collected when conducting averages was thrown out when considering the other yields collected. Possible sources of error are stated below. Following the procedures of this lab, it would be possible to find out the ions produced in any reaction that occurs, which is beneficial in the scientific community, especially in the field of chemistry.